Hello, everybody. We are a little bit behind schedule already, 15 minutes, so the faster we go, the sooner we will get to the wine part of this situation. So let's accelerate. Very good. So it's time to get a little bit more into the actual technology of how we are going to enable all these visions and use cases that we are discussing today. And first in line is the biggest telecom operator in Greece, very important technology provider here. Therefore, I welcome to the stage Mr. George Onopas from the OTE Group, who will talk to us about 5G, IoT, and AI accelerating digital and transforming life. Welcome to the stage.
Okay. Good morning from my side. Thank you for the invitation from Pinet. It's my great pleasure actually to be here. So as I'm coming from an operator, I will try to give you a flavor about, let's say, this sector, what's going on. So as today, actually, we're hearing all these fancy applications. In order this is actually to be true, actually, we need connectivity in place. Okay. So, about Cosmote Telecom, the OTE Group, is the undisputable leader in the Greek market, actually, and which has actually the majority of the investments in the sector. I can say actually that concerning the fixed, I have the privilege, to be honest, to lead the teams that they are doing the design and the planning of the whole access network in Cosmote Group. So concerning the fixed access, already actually the FTTH network can serve more than 2.5 million lines. And recently that we have actually a point in order to do the whole UFBB project, which is actually a project, EU funding, that brings the fibers to the remote areas. You can imagine actually that we will build the network for the next century, to be honest. But apart of the fixed access, of course, we have the mobile access network in Greece, which is the biggest and the best network. We managed actually 11 years in a row actually to certify it as the best operator in Greece from Umlaut, and 9 years on the row from UCLA. And about the 5G, actually, it seems as technology, it is the most fast-growing technology. So actually, through my experience, it took us more than 15 years to deploy the 2G networks, more than 10 years the 4G, and I can say for the 5G, actually, even though in 5 years deployment, the traffic actually that the 5G network served, it was amazing. I can say actually not only Cosmote, but and the other operators in Greece as well, they are in very good maturity of the 5G deployment. But you can see actually how fast it's growing. And this is because actually the increase of the traffic is tremendous. Every 2 years, actually 2 to 3 years, the traffic is doubling. And it's not only the mobile actually business, the mobile subscribers, it is the Internet of Things connectivity and the fixed wireless access. I will have some actually more information about fixed wireless access. So the fixed wireless access is a product actually that we can provide a connectivity like, let's say, the fixed lines, like the okay, I cannot say like fiber, but it looks like actually. But it's bridge technology, to be honest, that it cannot compete fiber. But this is the beauty of the mobile business, actually, that is fast and quick. So in order, let's say, to provide better services than the copper, it is the best bridge technology, the fixed wireless access. And already we have deployed it. We have more than 80,000 subscribers on that. And already actually it is served 20% of our traffic. It's amazing. And all over actually the world, it seems that the majority actually of the operators, they will use it as a bridge technology. So the 5G actually, it is an evolution of technology or a business enabler. Most probably the second one. But let's see actually some facts concerning the 5G. What it brings the 5G actually? It brings more rings connectivity, massive connectivity as well, less delay. It gives actually a better machine-to-machine connectivity. So all these, I can say there are benefits that are quite useful for this application that we have seen in the morning and we will see later on. For sure, actually, we need more spectrum. And that's why, I don't know if you're aware that recently there was a big actually debate concerning the 6 upper bands, if it will be allocated to Wi-Fi or to 5G or to mobile actually. Business that will be on mobile, for sure actually the majority of it. We need more spectrum, that's for sure. I think that I jumped one presentation, no, this, okay. So the IT, the Internet of Things actually is something that already have been arised. Even though the 4G was capable to provide this kind of connectivity over the narrowband IoTs and the CATM, but the 5G is coming with the red cap protocol. And I can say through my experience actually that the technology actually is here, can provide connectivity. This is that is missing actually, I think, is the application. So I think we will see later on as well that AI techniques, machine learning techniques will accelerate the usage and introduction of the applications. So it's obvious, I think we will see it actually today from the presentations, that the Internet of Things, they will reshape everything. We'll go to a new era, actually to a new digital era. The way that we will live in a couple of years actually in the future will be totally different than this one that we're living right now. There will be applications which already, I can say, that exist, but they are not yet massively used, is all over. They will be actually in the cities, in the smart cities. We have applications on factories. I can say that the fourth generation, the fourth industrial generation will come through the telecoms. This is already happening in China. In China, actually, they have developed more than 30,000 campus networks. It's amazing. So, applications, they will be all over. In the houses, smart houses. In the smart waste management, smart parking, everything will be smart. In agricultural, actually, in the vessels as well. Wearables for the health applications, health monitoring applications, they will be all over, that's for sure. And now, actually, the AI, the story of the AI. The AI is coming, and for sure, it will accelerate the usage of the applications. It's amazing, actually, in the last 2 years, the adaptation of the AI definitely will lead us in new digital experience, that's for sure. But not only actually on the application, but even though on the networks as well. It will help us a lot to improve the performance of our network and our monitoring of our network. Why? Because the telecom industry actually, it has in the gene data. Not only data, historical data, which is the best feed for the AI and machine learning. So for sure AI will be in our era, the telecom industry. And of course, all of this, they will create traffic, a lot of traffic, even though higher than this that we have seen. That's why we need spectrum and new techniques. But I think actually that the telecom industry is quite mature actually in order to overcome these kind of problems. So conclusions. It seems that the 5G and the 6G in the future actually is not only technology evolution, but is business enabler. They will help to monetize and to make true actually to accelerate the new digital experience that they are coming through the connectivity, but as well through the usage of the AI and machine learning. So the new era is already here actually. And let's see, because actually video is better actually for us, for all the people. Let's see a video that summarizes all of this that I have mentioned.
When everything becomes linked with everything else, matter becomes mind, and the possibilities become endless. Imagine 50 billion IoT connected devices by 2020. Now, imagine the economic impact of these connected machines. $4 to $11 trillion per year by 2025. Wearable devices, environmental sensors, agricultural machinery, components in a vehicle, or devices in homes can all be connected to deliver insights and drive transformation. So imagine if you had smart devices in your home, your car, your workplace, or even on yourself. The world becomes alive. That's Internet of Things. The Internet of Things is making everyday objects into data factories. When Internet of Things, along with big data, meets artificial intelligence, this interface will become enlivened with intelligence, and a new world will take birth, which will increasingly talk back to us. Imagine the kind of world that it would be. Imagine the revolution it will usher in the way we see the world. The external world will become the extension of our mind, like an extension of our thoughts. Imagine a world that is responsive, a world that is optimized for human creativity, a world that is intelligent. The Internet of Things is a breeding ground for new AI-driven solutions and experiences, from self-driving cars to intelligent homes to health. Welcome to the world of endless possibilities.
Thank you.
Thank you very much. As we move now from the terrestrial networks, in the recent evolutions of the technology, the space satellite networks are going to play a very important role, and they will integrate, and they're very relevant to Greece as well, because we have a lot of ships and boats in the Aegean. We have a lot of forests and firefighters and climbers and a lot of other people that can really benefit from this kind of services. Therefore, I'd like to welcome Dr. Angelos Goulianos from the European Space Agency to tell us how non-terrestrial networks converging terrestrial and space connectivity.
Anyway, okay. Okay. After this little adventure, thank you very much. I don't know if you can hear me. So thank you very much for the introduction. And thanks again to PNet for the invitation and for putting together this amazing event. My name is Angelos Goulianos, and I work at the European Space Agency as part of the 5G, 6G strategic program line. And I would like to start today's presentation with a simple observation that satellite and terrestrial communications are no longer two different worlds. They are actually bridging together a lot of common functionalities. And of course, I will come back to it later on in my presentation. But I think for those of you who are not familiar with the European Space Agency, I would like to give an overview. So ESA brings together 23 member states. And also it has a workforce of 5,500 people and plus. And this workforce is spread across 11 directorates. The activities are spanning from Earth observation, telecommunication, space exploration, and navigation. And the agency is supported by its member states through significant investments, and including the 22 billion that recently were allocated as part of the latest Ministerial Council. And a fair portion of this budget was allocated to telecommunication and also non-terrestrial networks. So the question is, why is Europe investing so intensely on non-terrestrial networks? What is it all about? And I think to understand what is actually happening, we need to take a step back and see how the satellite telecommunications have been involved over time. Initially, satellite communications were addressing quite a niche market, and it was mostly dedicated to business modeling. And it also had closed interfaces, proprietary interfaces, quite complex subsystems, which are actually quite expensive in order to reach the end user. Everything has changed, though, with the adoption of satellite communications in the 3GPP standards. That, for those of you who are not aware, 3GPP is actually the community that drives the terrestrial mobile standards. So, starting from release 17, the satellite element is a part of the full ecosystem, and where the satellite element is the terrestrial standards were kind of adapted in order to accommodate the particularities of the space segment. And this was a major milestone that happened back in 2022. And of course, then we have the release 18 and 19, where this convergence became even more meaningful. So of course, this has a huge impact because we are now moving from a niche market to a business-to-consumer market, and this opening the doors for a lot of profit, of course, to the satellite industry. So imagine for services like direct-to-device, we have, let's say, 5G smartphones, we're talking about 5G CPEs, Internet of Things that can connect directly to the satellite. And so how does ESA support this convergence of terrestrial and satellite comms? So we mainly do this through participation in industry fora, and we're working very close to GSMA and Global Satellite Operation Association. We are working very close with alliances such as ORAN, Seamless Air Alliance, and many others. Of course, the most important thing we do in ESA is to drive the standardization. So we do that for over 10 years with delegates to 3GPP that are supporting this evolution and the inclusion of satellite to the terrestrial domain. Thirdly, we have a bunch of projects actually ranging from very small feasibility studies to large-scale deployment and product development together with industry. And finally, we advocate for the adoption of non-terrestrial network hubs. And I will come back to that later on in my presentation. So this is our vision. This is our vision on how 6G and NTN should work together. And first, we are moving forward a 3D network topology where ground, air, and space should work as a seamless, unique system. Mobility is also a key factor in 6G, and definitely the requirements of 6G cannot be met by just having terrestrial connectivity. We need also to associate the mobility with satellite connectivity, especially when it comes to autonomous networks. Thirdly, we should advance on standardization because standardization brings together the two worlds and create a framework that the two worlds can communicate together. And finally, we need to bring in new technologies. So, for example, we are working towards merging RF and optical communications. We are working to develop new waveforms that are adapted to the satellite links. We are working in joint communication and sensing and many other technologies. So currently we are running over 100 activities related to 5G, 6G non-terrestrial networks, but of course I will briefly mention some of them, which I think are quite important. So Helena is the project that it actually supports the drive to the 3GPP standardization. So we have formed a consortium with significant industry partners that are actually driving the standards in 3GPP. Last year we have launched a mission which is called Remi Lide, and this mission was one of the first missions to test 5G waveforms over transparent satellite links. Transparent means It's a bandpipe architecture, and the UE and the G node B are on the ground. We also have a public-private project, which is a 5G merge, which is over 60 million project. And actually, it's all about bringing connectivity to the edge by using satellite assets. And finally, we have the MIXELS mission that will be launched next year. And this mission is about launching 2 satellites that will test and that will develop and test various configuration of radio access networks in space. And also new technologies for inter-satellite optical links. In particular, I would like to mention a very important key project, the 6G LINO mission, which is about to be launched in Q1 2027. I had the privilege to lead the study before we create the RFQ to industry for this. So this is actually, we're talking about an in-orbit 6G laboratory. And what this is all about, it will test and validate technologies ranging from AI-assisted dynamic spectrum management, reprogrammable payloads. We will also have handovers between space and terrestrial 5G nodes. And finally, we will have radio intelligence on board, and we'll test new waveforms. But of course, although launching satellites and operating satellites is quite exciting, as you understand, most of the work should take place on the ground. So we need to design, develop, test, and validate the technologies before they move into orbit. And this is why ESA is heavily invested in the NTN hubs that I have mentioned previously. So the NTN hubs are places for collaboration between industry, academia, and ESA engineers in order to mature the technologies and launch new missions on this field. We have 2 such laboratories in ESA. The first one is in the UK, the one that I'm managing. And we also have another laboratory in ESTEC. So this is a very high-level overview of the UK ESA hub. So you can see we have a wide range of user equipment from smartphones to AR, VR devices, IoT, which are all connected to carrier grade and also experimental networks. On top of this layout, we have a large pool of satellite connectivity encompassing both low Earth orbit and geostationary satellites. So for example, you can see we deploy Starlink, OneWeb, Eutelsat. We also have some simulators in order to do some more advanced experimentation. And for the past 2 or 3 years, actually, we have tested over 15 products from industry, both software and hardware products. So this is the layout. I mean, just it's a bit complicated, but I will very briefly mention this. This is the ESTEC layout. So this is the hub. It's a kind of trying lower TRL technologies. It is built upon software-defined radios, channel emulators, satellite terminals, and RF switch matrices. And we had, in this hub, we had the world's first 5G link over a low Earth orbit satellite, which marked a significant milestone. So, since we have acquired all this experience in building hub, we thought, okay, why not scaling the hubs all across the European member states? We need to accelerate the expansion all across the spectrum, and we are currently developing hubs in many countries like Belgium, Romania, UK, and many others which I cannot disclose right now because the contracts have not been signed. So there are also ongoing discussions with a wide number of member states. But of course, I would like to emphasize and say here that we believe that Greece has all the necessary potential to be the next NTN hub. Why? Because first, Greece has a very important geopolitical positioning, and also working with Greek colleagues, I know that really capable in engineering domain. So Greeks are great engineers, actually, right? So also, this will not only strengthen the digital economy of the country, but it will position Greece as the #1 player in the Balkan and the Southern European area. So, next slide. How does CISA support the telecom industry? That's a question that we often get questions from industry on this and from academia. It's not a very simple process, so I cannot go into very deep on this, but I will just explain the basic pillars. So we have the ARTES program, which stands for Advanced Research in Telecommunications, and the ARTES program has actually two main streams. The first stream is focusing on low TRL developments and activities that are fully funded and initiated by European Space Agency. The second stream is called Competitiveness and Growth, and this is actually for technology de-risking from an industrial perspective, and also it has all the steps from definition down to the product phase and demonstration. This particular stream is a co-funded activity from 50 to 75%. For those of you who are interested to know more, maybe we can have a catch-up during the coffee breaks. So, ESA is currently working a lot with Greek industries, right? So, we have concrete projects that we are managing together, and so far they are quite successful. This project range from protocol stack development for 5G solutions for direct-to-device services, and also for in-orbit assembly of large antenna arrays. Of course, every year we publish the ESA work plan, and there are some key upcoming activities in the area of onboard processing, open radio access networks for NTN, for non-terrestrial networks, and some new waveforms to be optimized for the satellite links. Of course, this is the link. Hopefully you can get this presentation and you can search yourself if there is any activity that's of interest. You can have a look and probably why not bid for it. So before I conclude, and sorry if I spend a bit more time, I think it's important to highlight one of the major activities that Greece is running together with ESA and the European Commission. So we're talking about the Greek National Space Program, which is one of the largest activities ever happened in Greece. This activity is around 200 million, it's being funded by EU, and it's been implemented by European Space Agency, of course in collaboration with the Greek industry. So we are not talking here about just one activity, we're talking about a multitude of activities and that spread across the full spectrum. This program includes the launching of 7 CubeSats and even more. Some of them are already in space, with very few remaining to be launched very soon. The CubeSats are targeting technologies like optical links, environmental monitoring, spectrum monitoring, IoT, 5G, and many others. So, one other important part of this program is the development of 3 state-of-the-art ground stations for optical communications. So this ground station will also test quantum key distribution key, maybe for the first time in Europe, utilizing existing ESA satellites, like Eagle-1, if you are aware of it. If anyone, I'm not sure if you are aware of it, but there are some experimental satellites that try to manifest QKD. And finally, and I think most importantly for the economy of the country, Greece is developing a Hellenic assembly, integration and testing facility. This is all about developing testing facilities for thermal vacuum testing, for vibration testing, and for telecommunication testing before launching a satellite. And this will definitely position Greece in the forefront of future space communications. So it's all about industrial capabilities that are all coming to Greece here. And with this slide, I would like to thank you. Thank you for your attention. I missed the last slide, but okay. Thank you very much.
much. Let's keep moving. It's time now a little bit to show you what we are doing. For those of you who are often wondering what actually PNet is doing, we have our very own Maria Marinidou to describe to you a little bit of the latest network technologies that we're working on, which are enabling value creation across verticals. Welcome, Maria.
Thank you for coming, everybody. So what I will try to do in this presentation is actually to bridge everything together. We have talked about applications, digital twins, robots. We identified the need for connectivity. So how everything works together. Over the past years, we have been talking a lot about 5G, about connectivity, about new capabilities. And as already described, we have made significant progress. But actually, the discussion now is shifting. The real question is no longer what the networks can do, but actually how the networks can provide value to the applications, eventually to the verticals. Because as we consider, connectivity alone is not an outcome, but what connectivity provides is the outcome. If we see the market today, the issue is not technology. I think we already know that technology is there. We have invested heavily, networks are deployed, capabilities exist, and we already identified there is a potential impact of the technology to different sectors, like defense, like tourism, XR, smart cities. But what actually we see here is that deployments remain fragmented. And adoption is still slow. We mainly see that 5G is used by IoT, broadband, and FWA, but we don't see so many verticals on 5G. And we often, if we talk to the operators, I think they will tell you most of the time that the return of investment is not very clear. So the question is not exactly what if the technology exists. It clearly does. The real question is that how you can translate it into a measurable impact. So what are the key capabilities that make this possible? Apart from throughput, apart from spectrum, the first one is programmability. For the first time, we see applications that can actually influence how the network behaves. The second, we see dynamic performance. The network can adapt according to the application need. Not all traffic at the moment in 5G can be best effort. Best effort is internet, but an application of robot cannot be best effort. So we need a network that can dynamically adapt to the application need. And third, it is observability. It is very important to see visibility end-to-end, from the application to the network. And if we imagine a case like a tourist being in a very crowded place like Acropolis, trying to use an XR application. If we put this traffic into best effort together with the internet, this application will never work. I think Ali showed before the avatar in Sunio. You have realized that this was very slow. Why? Because actually it was using the same network that all the others using internet were, the same network with a best effort internet, let's say. So you understand that actually it is very important to have networks that adapt. And, but how the applications can control the network? Well, there are different ways to do that. Definitely applications have specific requirements and they can define intent. Of course, we can do that manually. As engineers, we design the 5G network to adapt to specific application need, but now we are one step further. The application itself, the applications can actually interact with the network through standard exposure APIs. This is a topic actually we have been discussing a lot for many years, never happened. Now it's a reality, it's actually working in our lab as well. So, so the network does not actually behave statically anymore, but adapts and allocates resources dynamically. This leads actually to predictable performance, leads to real-time adaptation, it leads to efficient use of network resources. But actually, control is not enough. The performance needs to be delivered and needs to be validated. Performance is not something that comes with a technology. It must be engineered. So on one side, we have different capabilities and different mechanisms. There are a big number of mechanisms we can use. You have heard about slicing. We have heard about quality on demand. Now we have advanced mechanisms on the radio side. We can even control low latency, low throughput applications that require low latency based on specific mechanisms like L4S. For 5G, we can also do radio partitioning. We can use specific part of the spectrum to specific applications. So mechanism is there. On the other side, we can measure it through application APIs and network APIs. And of course, correlated APIs. It's very important to mention here that it is the first time that actually it's very important to measure and correlate network APIs and application APIs. A delay on application layer needs to be mapped to network API. So whenever there is an error on the application, we need to understand what is happening underneath. So this is a continuous loop. We need to measure, we need to adjust, and we need to validate, and it needs to be continuously in order to ensure performance. And this actually brings us to a missing layer. Modern applications have different layers. We have the foundation layer. We have edge cloud. Normally, low latency applications run on edge cloud. We are talking about AI. We're talking about a number of devices. What is important and what is the challenge is that this is a full stack, very fragmented, and needs to work as a one coordinated system. We often see the individual layers, but we don't see the full stack. And what happens in that case? When the performance is not as expected, or when there is an error somewhere on an issue, is most often a challenge to find where actually the problem lies. So this is what actually we believe, that we need vertical applications, new applications, robots, digital twins, avatars. It needs to be validated before going to production, and needs to be validated in real conditions. And this is actually what we are doing at PNET. We started we provide one integrated environment that brings all these capabilities together. What I mentioned in my presentation is something that already exists in our lab. We started by validating individual components across the network, applications, and infrastructure, but we realized that we don't have to stop there, and we need to move to end-to-end validation. So at the moment, we have validated more than 20 use cases across 6 verticals, using real scenarios, real requirements, and the real network conditions. Of course, when we are testing, we are not testing to an empty network. We create congestion scenarios, so that's why I mean real. Because somebody will ask, how can be real if it is not actually having live traffic? We simulate live traffic. This gives us a technical capability, but a real also operational experience of how the system behaves end-to-end. But what is important to mention is that we don't stop here. We have identified through our testing many gaps, and this is something that actually is happening daily. And we want to overcome these gaps. So we innovate, we create new solutions. So it is not only about testing, it's about continuously improving. Our vision is not to provide a single environment. Today, of course, we have a carrier-grade network lab. It is provided by a big supplier here in Greece. We are using also commercial spectrum. So it's actually a lab that is similar to what an operator has as a lab. But we want to expand it. We want to scale PNET into a federated environment. What does this mean? We want to include more sites. We want to include non-terrestrial access. We want to include platforms, XR, digital twins, AI, analytics, and we want to cover key segments like defense. We believe that the value is created in the systems that are validated through different environments, not into an isolated lab. This is the reason why we have this vision. So to conclude, the future is not about connectivity. Connectivity clearly is an enabler. It is about how we can provide predictable impact and how actually we can use this application, this connectivity to enable applications and provide new revenue streams also. So just to close, we believe that we need end-to-end validation of all vertical applications in real conditions. Thank you very much.
Thanks, Maria. Now we come to the presentation that I am most excited to hear about. We are in Greece recently focusing more and more on defense technology, and therefore it's a great pleasure for me to welcome Dr. George Pouraimis from the Hellenic Center of Defense Innovation, as we know it in Greece, ELCAC. Welcome, sir.
Μπορούμε να κάνουμε και το πελάκι. Hello, good morning from me. Thank you for inviting us and give us the opportunity to tell you, to present you about ELCAC, the Hellenic Center for Defense Innovation. I'm George Pouraimis. I'm a captain in Hellenic Navy, and I'm the Hellenic National Focal Point for the European Defense Fund. So actually, HEDI is actually bridge the gap between the military needs and the industrial capabilities. And wanting to see why we exist, why ELCAC exists, we need to have a first look on the global landscape. So we have seen so far that there is an increase in global defense spending, and we involve geopolitical balances, and we see that there is a volatile geopolitical environment, as I said, and so there is a demand for EU defense to synchronize with all of these. We have noticed that there is a Greek paradox. On the one hand, we have high potential, as we have seen that Greece has the 5th rank in EDF participation, and we are third as coordinators in research programs. On the other hand, we spend a lot of money, almost the 3.2 of our GDP in the defense, but we have seen that only the 0.7% of the GDP has a contribution from domestic defense industry. So this gap actually is not a failure, but we have seen it as an opportunity, a great opportunity. So ELCAC actually works as a catalyst, innovation catalyst, and we have 3 core functions. We support program and fund innovative defense R&D programs for Greek entities. We create an efficient communication between mechanism between actually the needs, the operational needs of the armed forces and the market. And lastly, we map the ecosystem that are related to defense and dual-use products. Our company, ELCAC, actually established in 2024, Our shareholders are the MOD and the Growth Fund, and we financed by the 2.5% of the MOD armament budget. And our valuable asset is our persons, our human capital, which mostly are armed forces personnel. We have private sector experts and PhD graduates fulfilling their military services. Our mission is to build a robust and sustainable domestic defense innovation supply chain to accelerate the development of dual-use technologies. And this mission actually leads to our vision, our long-term vision, which actually is to establish Greece as a center of excellence in defense and to cultivate a robust domestic defense ecosystem. To be honest, now we are the only country in EU that we have the support of the technical support instrument of European Union in defense. That's why we believe that we can be a center of excellence in defense. We know that this vision is quite ambitious, but we are sure that we can export innovation within NATO and EU frameworks. Of course, for doing all of these I described, we need an operating model. We know that innovation without direction is just an expensive hobby. That's why we have created our operational model, having a roadmap that is connected with the Hellenic National Defense General Staff in collaboration with the MOD, the Ministry of Defense. They produce the strategic plan for R&D. We get this strategic plan, and then we proceed and we announce calls for proposals. So, actually, LCAC has a strategy that is segmented to 4 segments: defense industry, startups, academia, and investor and financial institutions. Why? Because we have understood that these 4 segments have different needs. For example, a researcher from academia has different needs from defense industry. So our goal is to match each R&D project with a technology domain and a specific TRL. And we have used the SPEA, the strategic plan for R&D, to identify the 12 thematic areas related to defense. These areas are from space systems and cybersecurity to unmanned system. And this ecosystem actually covers a full spectrum of modern warfare. And we have mapped as well our defense and dual-use ecosystem. We have in our defense ecosystem, more than 600 entities. Some of them are companies, research labs, and we have a matrix of more than 400 technical experts in defense and dual use. So our ecosystem, we have seen that actually has a heavy emphasis on innovative SMEs. And then in our operational model, we have some national instruments that leads to R&D contracts. So we cover from research to prototype testing for low TRL to high TRL. For low TRLs, we have the innovation challenges, funding for academic research projects. For medium and higher TRL, we use the request for information, preliminary, which are preliminary consultation without field demonstration, and that leads to requests for proposal, RFPs, which actually are the award of a public contract through competitive dialogue and through negotiated procedure. So this is the TRL pipeline that we use for national activities. Except of these, last year in 2025, we announced 5 innovation challenges, giving opportunities to our ecosystem to funding, acceleration, and pre-commercial procurement. We have our military academies technology transfer office for transfer technology and know-how from the military academies to the market, for protect the intellectual property of the researcher and supporting them to create spin-offs and startups. Last year we announced 4 scholarship awards, 4 PhDs to the military academies. Each of the scholarship award was 200,000 euros, and actually most of the funding was for lab infrastructure and equipment. So last year we announced, at the beginning of every year, we announce the R&D strategic plan, R&D calls. Last year, actually, initially, we had 17 R&D calls, and we managed to implement the 14 of them, funding approximately 90 million euros. But except of the national instruments, we participate to international instruments as well. So we have the research, we support the research program funding under the European Defence Fund, the EDF, which actually has up to 100% funding coverage for research activities by EU. ELCAC supports Greek entities giving a letter of support for having a role in innovation and in research. For medium to high TRL, there are development program funding by EDF as well. Work packages funded by EU up to 50 to 100%, and the remaining cost covered by ELCAC. Another R&D program funding is the European Defence Agency, EDA. Actually, it's fully funded by ELCAC, and a program launched through the EDA CapTech structures. About the non-financial tools that we provide for supporting defense ecosystem, we are the funders of the NATO Diana defense accelerator for dual-use products. We support the EUD's accelerator. We have, as I have already mentioned, EDF National Focal Point Office to inform our ecosystem and to provide support to matchmaking. We have implemented many educational and informative webinars, pitching arena, network matchmaking with participation in international exercises. We support our ecosystem to test their dual-use and defense products to test centers, and especially during operational exercises of the armed forces. As I mentioned, we have already mapped our ecosystem, and we'll continue with this. And actually, ELCAC secures today and tribalize the future. Greece is ready to lead defense innovation. So we have the skills. I think that we have the structure and the political will to achieve it. Thank you very much.
Thank you very much. We will remain in the area of defense. I believe we have only two talks left before lunch, so this should go quite pleasantly and quickly. But we will remain on this topic with this with two talks. One from a local leader, Intracom Defense. I welcome Dr. Chris Avgidre to talk to us about AI in defense applications.
Well, good afternoon to all of you. It's our pleasure to be here, and I would like to thank PNet for this invitation. Actually, I'm Chris Avgidre. I'm Deputy Director of the New Technologies of Intracom Defense. Actually, Intracom Defense is an outstanding company in Greece in defense and security sector. Our core business are tactical communications, unmanned systems, and hybrid energy systems. What we'll discuss today is an strategic shift in the military domain by using AI. Actually, right now we are moving away from hardware-centric warfare to what I could call algorithmic warfare, and this is something new. In my presentation today, we'll see the technologies that make this change possible, the applications on the battlefield, and actually the standards that governing all of them, because we are all afraid when we hear AI defense, as you all understand. Actually, there is the big trend as of today is a shift from automation by doing a task to autonomy, make a choice. What we also see nowadays is that we have a mass production. Historically, when we speak about defense, we all understand that we are built few and very expensive platforms, let's say aircraft platforms. But right now, we see the rise of the development of low-cost systems that are smart enough to do their job and of low cost that can be lost in a combat. And this is something that is a great change and that leads to a new era of the software-defined defense. Well, AI actually provides to armed forces right now access decision superiority across many domains. What they can do, they can observe, orient, decide, and act faster using AI technologies. And let's see some applications in the defense sector. One major application is, of course, the intelligence, surveillance, and reconnaissance. ISR actually is the most mature application of AI defense, with making tasks like automatic target recognition, change detection, image intelligence, signal intelligence, and so on. Of course, we all understand that we use AI right now in autonomous and unmanned systems. We are shifting beyond piloting, remote piloting systems to fully autonomous flights. And we have to operate systems in GNSS-denied environments or jammed environments, and AI helps a lot in this. We also have AI in cyber warfare and network security. We use AI, for instance, to define zero-day threats or we use AI to form self-healing networks in autonomous response networks for defense. We also see AI in predictive logistic readiness. What we have done using that is that we managed to have a condition-based maintenance that leads to supply chain optimization. And one last application that we like to mention here is the bad management decision support, as AI helps commanders navigate complex environments but by synthesizing data by all domains. What is the trend right now in military strategies is what we call joint all-domain command and control integration that fuse data from all domains, space, air, land, sea, and cyber, into unified common operation picture. So we see AI in all domains of defense, land, sea, air, space, and cyber, and we can imagine many use cases that this is used and has great impact providing design superiority, information superiority. But let's see what actually right now are the technologies that are making this shift. The technologies, there are many, but what we see nowadays is that the trends in computer vision for real-time target classification, the agentic AI using in autonomous mission planning, the swarm logic, because we see now hundreds of drones that communicate together and be as one unit, and without swarm technologies, this cannot happen. And of course, the changes that we have in AI hardware acceleration. Okay, are there any challenges for AI adoption in the defense domain? 5 years ago, from my department, I said that we can use AI in our platforms, and everybody laughed. But at that time, it was just experiments in platforms. But right now, there are real requirements for the systems that we develop. But however, there are many key challenges, and some of them are the AI changed the status quo for military system qualification and certification. This is not easy when we don't have explainable AI or standards that support this development, the qualifications, the certification of the real system. Shortage of AI talent, okay, this is problem to worldwide, and this is more acute in Europe, but there are more challenges in defense, as you all understand. And why? Why AI is booming? Academia and government struggles to keep up. Europe is still spending less for AI R&D activities compared to US and China. And other challenges there are. One is shortage of training data. AI means data, but the data in defense domain are not so easy because you cannot take data from the open sources. You cannot share data between MODs. And that's the thing is becoming very difficult. Of course, there are many solutions like mixture of real data sets from the operation, open source data sets, data accommodation techniques, and synthetic data sets that can help in this direction. And another challenge is, of course, the AI standardization activities. Ethical deployment. For sure, it is needed. We need ethical guidelines in defense AI, and this needs global collaboration in military AI regulation. The European Defence Agency in Europe, I will say that acts as an ethical guardian for the EU military AI. All activities that are done in Europe and more or less in Western world is that are strictly aligned with a human-in-the-loop doctrine. That means that the person is that the one that finally decides. And also the AI assets and all the developments comply with international laws and the EU AI Acts for the dual use implications. NATO and Europe make many activities right now to develop international standards in order to enhance interoperability and enhance trust. Otherwise, they cannot be used in any of these cases. All these activities are done with the core, under the core doctrine that a standardized human in the loop, or in some years human on the loop architecture, is present to maintain accountability and compliance with the standards. Let's see some activities that happen right now in Europe. All the defense military strategies and the white papers that have recently announced for the defense, they all underscore the growing importance of AI defense. AI-powered defense innovation is progressing with multiple European Defence Fund and PESCO programs. The EU is promoting synergies between civilian and defense research and innovation because, as we all understand, AI is spin-off for defense. Many things happen in the civilian world. And EU and NATO cooperation, they all know that deeper collaboration is needed in this domain. I mentioned here some of the EDF products that they make large-scale multinational efforts aimed at delivering operational AI-based prototypes for the modern battlefield. I have mentioned some programs that we also participate in some of them, or we coordinate some of them. The last two of the projects are projects that the Greek MOD is the coordinated entity of the project, and Intercom Defense is actually the coordinator of the project, the project of Proteas and Actus. There we have real use of AI for operational prototypes, either in the Special Operation Forces Command Post Command and Control, for ISR and decision support activities, or in our Actus, which is the Lotus Tactical Air Pass, with AI-based ISR capabilities also. The European Defence Agency serves as the central hub for military AI across Europe. Through the Hub for EU Defence Innovation, they make operational experimentation, and they also do dual-use scouting. And through the strategic research agenda and through the capability technology groups, actually technologies like federated learning standards, explainable AI, or edge AI computing are a need and a must. And I stop my presentation here, saying that the investments are shifting from steel and engines to chips and codes in the defense domain. We are entering a new era of the software-defined military, and actually AI, what it does, it ensures decision superiority in an algorithmic age for the defense. Thanks for your attention.
Thank you very much. We are now almost at lunch, so we will be as brief as possible. Everyone is talking about how great and big their armies and defense are, but nobody is ever calculated how big the European power would be altogether if we manage to eventually collaborate and create a joint European defense system. The technologies, we are already working with with various leading countries, and we're very happy here to have today with us two of the leading technologies countries in Europe. We have our great colleagues from Latvia and our next speaker from Poland. Please welcome Dr. Sławomir Pieters, CEO of IS Wireless, who is going to talk to us about Open RAN to Tactical Resilience, leading the evolution of dual-use 5G. Welcome.
Trying to wake you up a little bit with this short clip before lunch, so I promise not to be too long with my presentation. My name is Sławomir Pieters. I'm a CEO and founder at IS Wireless. It's my pleasure to be here, especially that Greece is a very important place for me, because that was the place exactly 20 years ago where I had my first practical experience during my studies at OTE in Athens. I spent 3 months working with X25 protocols and Stroger switching center, as far as I remember. Okay, I'm going to talk about the transition we have made as a company, because we committed ourselves fully to defense, and we went through the open radio access network concepts, but the necessity made us really focus. Now, there are pretty many similarities between Poland and Greece. We both have very difficult borders. While Greece has probably the longest coastline in Europe, while we have flat terrain, these are very difficult borders, and we have tough neighbors. The company has been born very much out of years of research and development. I am proud to be part of multiple research projects still up to now, but what we were growing from is truly a collaborative European research. So the technology we developed comes directly out of this collaboration with the top European institutions, as well as from the collaboration with the Polish army. In a nutshell, we are building a software-defined networking layer that changes the future of how the networking is provided. And I do agree very much with the previous presenter from Intracom that there is a change in a warfare where it is a much more software-defined activity, where hardware, especially the legacy hardware, becomes commodity. So it matters a lot how we manage the hardware and how the actual functionality behaves. and that's what Liquid Radio Access Network is about, which is a software-defined mesh technology, setting up new way of providing ultra-resiliency. Very brief about the company itself. We already have a very strong traction with NATO MODs. Yeah, we are deep tech. We have a portfolio of almost 20 patents. The order intake for this year exceeds 20 million of US dollars. We are tripling our revenues year to year. We have almost 60 professionals, and we are expecting a high growth. So by many, we are considered to be like a leader among those small companies addressing the defense connectivity or defense software provisioning market. So what problem are we solving? That's the clear classical problem of the last mile connectivity in contested environment. As a matter of fact, there are no good solutions there. Commercial public networks are not really applicable because they are shared resources. The warfare waveforms are not applicable because they are very well recognized by the enemy. Satellite communications cannot provide adequate capacity per square meter. And conventional 5G is not really prepared for jamming, for threats, for changeability of the actual provisioning of physical network nodes. So this is what we are solving. And Liquid Radio Access Network changes the network architecture in a way that it behaves like a mesh network. There is no single point of failure. So you can destroy nodes, but the network will prevail. As such, this network is extremely easy to deploy and very fast and very difficult to kill. It can run on any type of hardware resources because hardware is a commodity. We don't care that much about it. It's survivable by design. That's obvious. There are no single point of failures. It's very much AI adaptive. We are solving this problem of lack of data for AI algorithms because our patented technology drags this information out of the underlying protocols and out of the underlying network nodes. It is sovereign and secure because the entire value chain has been produced and developed within NATO countries. And it uses civilian waveforms. It can be 4G, 5G, 6G, whatever. They are useful, especially in a situation of a hybrid warfare, because they can coincide with the civilian transmissions. And I think that hybrid warfare is much more probable than a war like we may know from like the Second World War. A couple of use cases that I wanted to show you, which are already deployed. The first one is force connectivity, building so-called tactical bubbles around infantry vehicles or tanks. The second one is hybrid defense, setting up a network at the borders of the pact in a mixed form of fixed and mobile nodes. Then emergency services, that's a typical PPDR case where you have mobile network nodes and you are providing connectivity, but for civilians. So this is what we are doing with police. Industrial IoT, but in situations where you have tough environment, and last but not least, connectivity for drone swarms. So these are all the real cases that are already deployed. Some of them are very well advanced. Like I can tell you that our networks are running at the borders of the pact, very close to Belarusian border. So they have multiple goals, I would say, to carry out. Some others are built, like for the Polish police. Some others are tested by the other NATO countries. The customers are happy, so I just skip this very much. And just to conclude, I started by highlighting that all these innovations and the rising commercial success comes out of research and great European ecosystem. And this is what I would like to highlight, because here are many of us with this research background, and I think it's a very great value that we have in Europe such strong institutions, and we know each other very well, and it's an asset that we should really utilize to change this world for good. And Europe has a huge capability gap in terms of intelligent systems to be created, of course. So why not to change or transform this challenge into opportunity? This is what we are thinking about. Just to conclude, I would like to also thank, using this occasion, to NATO Diana program. We are part of this prestigious program. We got into the top 0.5% out of 2,700 companies last year. And I'm really strengthening collaboration of the European institutions, especially with large ecosystems such as Digital Catapult from the UK, 6G Future Network Services from Holland, from the Netherlands, and XG Alloy from Germany. So my ask here is, I would love to collaborate with you guys on any stage of such novel systems design and development and deployment at the end of the day. Thank you so much.